Hello everyone, good morning, good afternoon, good evening, depending on when you decide to watch this session. My name is Sumit and we have been doing OM, which is Operations Management together. Let's do a quick recap. What I'm doing is I'm trying to finish off all the small topics and then venture into the big topics. Now these small topics were actually not this small. They had like a lot of questions in them, but after they kept redefining and redesigning the module, they kept reducing the number of questions and then it became less fun. Anyway, we are done with creating a forecast. Once you've done creating a forecast, we've done planning a location according to that forecast. After that, we planned a facility according to that location. In that location, after that, we created an aggregate plan. So we broke down the yearly forecast into patches and then we understood how we are going to produce in these patches. Then we did something called as productivity and capacity planning, where we understand what my capacity is. Do I need to increase or decrease production to meet that capacity? Or there are two types of capacities. One is what you want and one is what you have. If what you want and what you have is the same, fantastic. If it is not the same, then you need to make changes to incorporate what you want. We did a little bit of productivity also, where we tried to understand that if my organization is working at a certain pace, is that pace good enough or not, depending on what is the standard pace at which they should be working. These were the topics that we did. After this, once I've understood productivity and capacity, we did scheduling problems, where when a job comes to me, how do I schedule it? So there were different ways of doing it. There was FCFS, first come first serve, last come first serve, shortest processing time, longest processing time, and so on. So we saw how does it change or what changes when you change the sequences of the jobs. After doing all of that, the next topic that I'm going to do, frankly, should have been the first topic that we do. Or this topic should at least be a topic that should be done before capacity planning. But because it doesn't have that much connection, but if I do this, then not that understanding capacity planning is going to change in any way. No, it's just a part that we used in capacity planning and we didn't question ourselves that where did this part come from? And that is a part called a standard time. When we did capacity planning, you must have read in a lot of places where at least two questions I distinctly remember. One question was the pocket transistor radio, where they clearly said that the standard time for one unit is 30 minutes. Then there was another question where, remember, we had to inflate and deflate the time, where they said that the man takes 8 minutes if I'm correct and the machine takes 22 minutes on a standard basis. So on a standard basis, it requires 30 minutes to make one unit. My question to you is, who decided this standard time? Where did this standard time come from? In today's day and age, no matter what you buy, it comes with standards. What does that mean? When you buy a refrigerator, the refrigerator will have written on it what is the time for making ice. If I put a ice box into the fridge with water, in how much time will that make ice cubes is told to you. When you buy a washing machine, if I want to wash a half load, so washing machines come in different sizes, let's say. So if I want to wash half a load that the washing machine indicates, it will tell you how long does it take to wash half this load. If I ask you, how long does it take to go from Bombay to Pune? You will say on a standard basis, should take 2.5 hours. Where is this coming from? Where are the standards coming from? Where was it, or who told you that assembling that pocket transistor takes 30 minutes? Who told you that if I want to do that particular job, it takes 22 minutes on the machine and 8 minutes for the man to work? Who decided these standards? And that is what we are going to understand now. We are going to do something called as time and motion study. What is time and motion study? Time and motion study, as literally as it goes, is understanding the time taken to do a certain job and understanding the motion that goes into a certain job. Or in other words, it is achieving a standard time and a standard motion to do a certain job. What does that mean? When a job has to be done, we are going to find out what should be the standard time to do this job. So I know when somebody else is doing it, is it going to take more or less time? Or forget that. I will give you a basic example. Tomorrow you buy a machine that, let's say, makes pencils. Okay, and this machine makes one pencil at a time. If a vendor comes to you, if a customer comes to you and the customer says that, sir, I want 50,000 pencils next month. Tell me how much do I need to pay? You'll be like, 1 minute. I don't even know how long will it take to make 50,000 pencils. Don't you need to know the standard time to make one pencil? If you have the standard time to make one pencil, you will multiply by 50,000 and you will tell the person if and whether you can give him or her that 50,000 pencil order in the next month or not. If I am a bottle manufacturer, what do I make? I make plastic or silicone bottles. I have a friend who works in this industry. How does it work? Well, what it works is same. You have polyballs or plastic that you put into the machine. It heats up the machine. And there is a die cast inside that blows the plastic into the die. The plastic takes the shape of the die, which in this case will be either this bottle or it could be anything, this small container that you have. It could be or this. Don't ask me why I have this, but I do. This moisturizer bottle. All these things that are made out of plastic, what changes is the die that makes this or the casting that makes this. Apart from that, the basic procedure remains the same. So if tomorrow, who is this made by? This is, I think it's HUL, but not mentioned. No, it's marketed by Nivea India. Anyway, so let's say that this is manufactured by HUL, which is Hindustan Unilever. So Hindustan Unilever comes up to me and says, and this is true, the friend that I have, he makes containers for a lot of pharmaceuticals, where they come to him and they tell him that this is what we are looking at, or they basically don't give him a bottle, they give him a sample, which is a sketch, and they tell him this is what we are looking at, this is the kind of top that it is going to have, this is the kind of bottom it is, it's a straight hold bottle or it's a reverse hold bottle, whatever it is, and they tell him that we want or we are going to need 1 lakh bottles of these. In what phase and how will you give them to me? Now the question in hand is, when you throw something like this, which I have never done before, which I have never made before, how will I give you? How long will it take? What I could do is, I could give you a ballpark figure. What do you mean by a ballpark figure? A rough figure. I have made a container like this, not an exact like this, like this. So let's say I have made this bottle before, and I realize that both these bottles are going to take the same processing, and if they are, whatever the other bottle is going to take, approximately what you want is also going to take the same time. But will I be able to give you an exact time? No. It's okay for him. He doesn't even need an exact time. At least I need to know what the exact time is because I need to cost it. Depending on what time it takes, how much of machine element is required, how much is man element is required, what am I paying for the machine? So I have to understand if that machine is working for 1 minute, what should I charge for that 1 minute? How much electricity does it eat up? How much manpower is it eating up? If that bottle is going to take 1 minute to process, there's a man going to stand in front of it for 1 minute and I'm paying him a minute's salary. So that bottle should bring me back that 1 minute salary. All this to be understood, one very important thing is, what is the time to do this job? But another thing that is also very important is the motion in which the job is done. Now, what do you mean by the motion in which the job is done? Something as simple as you are writing notes. So you are copying notes, or you have a textbook from which you are writing down things. If you have a textbook from which you are writing down things and you sit down to write, or for that matter, the videos that you all are watching, you all must have your laptop or your cell phone kept in front of you in a certain position. Then you keep your books in a certain position. Some people like their books tilted, some people like their books straight, then they keep the other book in front of them, some keep the other book on the right, some keep the book in front and all the stationery that you require, the pens, the pencils, the erasers, the scale, everything on the right. What are you doing? You are setting up a standard motion of writing these notes down so that I write these notes down in the least time or in the most effective manner. When you are using a mixer grinder, where do you stand? Do you stand on the back side of the nozzle? And then this is the grinder and you put your hand around and then you turn the nozzle? No. The regulator should be in front of you. So you put the mixer in front of you such that the regulator is right in front of you. This is common sense. Nobody had to tell you that. But when I buy a new machine and a worker has to work on it, I have to tell the worker, where is he supposed to stand? Is he supposed to stand or is he supposed to sit and do this work? Because depending on how he does it, whether standing or sitting, his effectiveness might increase or reduce. And that is why having a standard motion to do the job is also very important, because once I devise the best way of doing this, I am going to do this job in the most efficient manner, which is without wasting time, and from that I will have a standard time of doing the job. So what is time and motion study? Time and motion study is a study of a certain job or of a certain production that I am going to do so that I develop a standard time and a standard motion. I'm very quickly going to run you through what time and motion mean. So, time and motion study. Time study, motion study. Meaning, time study is concerned with finding the standard time for performing a certain task, while motion study is concerned with finding the total movements of the workers while they perform a task. So in time study, we give time the importance. In motion study, we are understanding the motions that the person has to go through. Purpose. Time study is conducted to find a standard time to fix a fair day's work. What do you mean by a fair day's work? Remember when we did the absentees question, they said that the standard production is 300 units. What does that mean? What it means is, on a fair month where everything goes according to standards, a particular plant should make at least 300 units. So standard time is very important for me to decide if and whether my workers are doing a good job or a bad job for different reasons. Number one, if they are doing a bad job, I will try and find out why and try and make them better. If they are doing a good job, like the incentive bonus question, we are going to give them an incentive bonus for doing better than everybody else. The purpose of motion study is conducted to eliminate wasteful and unproductive movements of workers so as to increase efficiency. So what do we do in motion study? What do we do in motion study is, in motion study, we try and remove any non-required motions. And all of us do this. Whatever you learn in management, we all do this. It's just that we don't give it so much importance. You also must have done this. As simple as, I will tell you whether, now there must be a lot of girls that play cricket, fly kites also. I'm not being a sexist here. But I'm just saying that it's as simple as, if your cousin, a younger cousin, is flying a kite and you see them doing something wrong, you walk up to them and say, "Aisa nahi, aisa karte hain," and then you show it to them. Isn't that correct? What are you trying to do? You are trying to set their motion correctly. Whenever we have a kid in the house and we are teaching him or her to play cricket, we stand behind them and hold the bat, trying to show them the correct motion of doing that job. So we all do this. We do this everywhere. We correct people and tell them, do this, you will do this, do it better. Do that and you will do it better. Change this and you will do it better. So there are multiple things that we do in our day-to-day life also, that if somebody else is doing them for the first time, we try to tell them how to do them in a certain set motion, or they should sit and do it, they should stand and do it, whatever it is, so that they do it efficiently. Lastly, method of time study is a stopwatch study. I'll tell you what that is. And lastly, method of motion study is still cameras. So what do? You fix a camera and you ask the worker to keep doing it, and then you later watch the tape and then you decide, so he is climbing on the stairs to put the raw material. Let's do one thing, let's put a conveyor belt there. He is doing this from the right, ask him to stand a little on the left and do it. He's doing this with his right hand, ask him to do it with his left hand. He's using both the hands, ask him to use one hand on the lever, one hand on the knob. Or what I could also do is CCTV cameras, which we all know what CCTV is. What is CCTV? It's a closed circuit television camera. A closed circuit television camera is basically a private use camera where you have your own grid or your own circuit over which cameras are fixed, and they are sitting in one place and watching them. Or you actually sit and observe the worker doing the job. That is how motion study is done. I know it must be still sounding a little absurd. So now what I'm going to do is I'm going to give you a real life example that I had done when I was in college. When I was in college and we had to study time and motion study, my HOD back then said that you have to do any small project that you want to, where you can study the time and motion of doing something. But remember, the job can't be something that I already know the standards for. Do something interesting. So the good thing about doing a time and motion study is that what you can do is you can pick up any job that standards are still not available. What do you mean by standards are still not available? I will give you an example. Cooking. Suppose you have to make chapatis at home. And if I ask you this, you will not have an answer for it. Do you know what is the average time it takes for the person who cooks in your house? It could be your mom, it could be your dad, it could be your brother, sister, or you could have a maid, whoever it is. Whoever is making chapatis, or it could be you also. Whoever is making these chapatis, do you know what the average time or the standard time per chapati is? We don't do this because we've never tried to understand it. We've never tried to study it. But whoever it is in your house who's been doing this for years and years together can tell you one thing. So if they've cooked everything and it's just the chapatis that are remaining, and if you ask them, "Arey kitna time lagega? Mere ko thoda kaam hai," they will say, "आधे घंटे में हो जाएगा." So they know the overall time that it will take to do the job. They just don't know what is the average time to do that job. And this is where me and my friend Ruchira decided to do a time and motion study. And yes, as funny as it sounds, we decided to do a time and motion study where we decided to find the average time or the standard time to make one puri. And then we took it to our HOD. Our HOD obviously laughed, but she said, fantastic project, I like it. Go ahead with it. It should be a legit study. We said, okay. Question number one, where do we do it? So right next to my college in Matunga, I was in Ruia, so right next to my college in Matunga, there was this South Indian organization called Tejugaya. If you are a South Indian and you know Tejugaya, fantastic. If you don't, okay. So there's this small cult called the Tejugaya group where there is this hall where they have like social gatherings. Some people also have small weddings and other functions there. So there is a legitimate caterer. And my friend knew this caterer. So I spoke to my friend and I said, can you let me study the cooking section of this caterer? So he said, yeah, he's my relative only, I'll talk to him. I said, okay. So we finally had that we are going to study what is the standard time to make one puri. So in a given day, we will know that if we give them a certain number of hours, how many puris that group can make. So when we approached that person, the first thing that he said is, I am okay with you doing whatever. Number one, no meddling. Number two, be extremely clean and careful. Do not touch anything because it's food. And we say we agree with it. We do not want to touch anything. We just want to observe people. So day one when we went, we saw those people doing whatever they do. And we said, okay, what we'll do is we will make columns and we'll start writing down timings. कि ये करने के लिए इतना time, ये करने के लिए इतना time, ये करने के लिए इतना time. But when we went there, we realized that these people are playing at boss level. What do you mean by boss level? There is this giant, a giant dough of wheat. And then there is this one person who is making rolls out of it. And that person is making, like, even before I could blink, the person had already picked up some dough, rolled and thrown it onto the plate. Then there's another set of women who are just rolling it out. 1, 2, 3, done. 1, 2, 3, done. And I was like, what? Then there was another person who was picking up the plates, taking it to the other corner of the room where that person was frying them. And I looked at Ruchira looked at me and she said, this is not going to work. So then we asked the person, can we fix a video camera? Because there's just too much happening. Paying attention everywhere is becoming difficult. So he said, okay. So Ruchira and I said that we will focus on one element at a time. And that is the first thing that you do when you do a time and motion study. And see here, doing a motion study was not required because they had already set their motion. I was not going to go there and tell them, don't do this and do this. No. I did not want to be slapped by people there. Because you can't tell the school principal how to run a school. No. These people have been doing this for years. So the motion is set. All we are doing is a time study. So the first thing that you ever do in a time or in a motion study is that you break down the job into parts. So we decided to break down the job into number one, rolling balls out of the dough. Number two, or let's say this is making balls. Number two is rolling the balls in a raw puri. Number three, frying. We broke down the job into three parts and we said we are going to ask or we are going to put the camera to focus on one thing at a time. Now you need to understand that the speed at what they are doing this is madness. And if you want to check how long is it taking for that person to make that ball, it is impossible. You can't say, oh 1, write it down, oh 2, write it down. No. And that is where a stopwatch comes into picture. You will also have a stopwatch in your phones. If you go to the alarm or the clock section of it, you will have something called as a stopwatch. What does a stopwatch have? A stopwatch has minutes, so 2 points for minutes, then there is seconds, and then there is milliseconds. The moment you put start, and there will be two buttons here. One will be a start that will turn into a stop, and there will be a button called a lap button. So what you do is, the moment the person starts rolling, you press start, and every time he's done rolling a ball, you keep pressing lap. What will the lap do? The lap will keep tabulating the timings. So when you press lap, the first timing will be 0.05, which means the first job was done in 5 seconds. The next is 00.13. So you know that at 0.5, he was 0.05, he or she was done with the first job. At 0.13, he cleared the second, which means between the first and the second time the ball was rolled, it took 8 seconds. Then the third ball, you keep pressing lap and keep taking data. Once you do that, you will have a lot of timings for making balls. This time is called the observed time. This is the time that I have observed time. Number 2, you go to the rolling bit of it. Now you can't focus on all aunties at the same time. So you've just fixed the camera so that you can pan out everyone, but then you can only pay attention to one person. Again the same, she picks up the ball, start. She throws the roti, stop. She picks up the ball, start. She throws the puri, stop. This is how I keep taking the time to make the puri or rolling the puri. Now number 3, they pick up the entire plate and they go, and there's a huge vessel in which there is oil boiling, and they put the puris in, and the puris fry and they come out. Now this is happening in a lot. The first 2 are happening independently, the third one is happening in a lot. That's okay. You start when she puts all the puris, you stop when she pulls out all the puris, and then right next to it, how many puris were fried in that time. After doing that, you have an observed time to do the 3 jobs. How many times? It's up to you how many cycles you want to take. You take 5 cycles. So cycle 1, cycle 2, cycle 3, cycle 4, cycle 5. Well, we used to take a lot because you have to take a lot of data. So we had around 500 cycles types. But here I can't show you 500 cycles, so I'm only doing 5 cycles. So I have 5 cycles for doing those 3 jobs, and that is to do 1, which is making the ball. The first time it took 0.05 minutes, which is almost 0.5 seconds. Now just humor me. The second time when to do 1, it took 0.06. The third time 0.04. The fourth time 0.08. The fifth time 0.10. So sometimes it takes lesser time, sometimes it takes more time. That's okay. Then we come to do making the raw puris. Well, this is where I realized for the first time it took 0.35, second time 0.40, third time 0.25, fourth time 0.30, fifth time 0.35. Sometimes more, sometimes less. And then the last time, which is frying the puris, on an average 1 puri took, in the first cycle, took 1 minute, 1.05 minutes, 0.95 minutes, 0.65 minutes, 1.1 minute. Sometimes it takes more, sometimes it takes less. These are my observed times to do the jobs. Once I have an observed time, what I move on to something called as an average time. What will I do? I will take an average of all of these. Correct? Once I take an average of all of these, let's say the average here works out to be 0.8. The average here works out to be 0.4. And the average here, 0.08. The average here works out to be 1.0. So I have the observed time, which I changed into a average time to do the same job. Now what do I do? Done. You have an average? No. Take a total. Now if I take a total, this will be 8, 4, so 1.48 minutes. And this is my declaration that to make one puri, it takes 1.48 minutes. Fantastic. But you are missing out on a few things. And what is that? Well, you fix the camera and you observed them for like what, 10-15 minutes? Yes. But you know what happened after 15 or 20 minutes? One auntie's hand started paining. So she stopped. She started relaxing her hands. Another uncle who was kneading the dough stopped because there was no atta only to knead the dough. So he stopped. The rolling of the balls had stopped in between for some time because there was no dough from which I could pull out the balls. All this you didn't consider. And there's another thing that you also didn't consider, and that is it takes 1.48 minutes to make this puri. Is that correct? Average of 1.48. Now these people who are making puris have been making puris at this speed and at this pace, not now, since 10 years. That is why they've learned so much and they've become more and more efficient. My question to you is, tomorrow, if you ask somebody in your house to do the same and you tell them that there are like 10 people coming home for dinner, let's say 5 puris per person, we need a total of 50, let's say to be safe, 60 puris. Well, I had done a time and motion study. One puri approximately takes 1.5 minutes. So 60 puris is going to take what? At max 90 minutes. And when you say 90 minutes, the person who makes puris in your house is going to look at you and then say, "To khud hi kar lena fir." You know why? Because these people are way more efficient in doing the job. So let me now come to you with a different example. I have bought in a new machine. So what I do, I make PVC pipes. But I make certain kind of PVC pipes. Now what I'm doing is, I'm not making pipes. I am making the moldings of the pipe. So I'm making elbows where 2 pipes go in at an angle. So one pipe goes in and creates a 90-degree angle. I am making joiners. I am making splitters. Well, 3 pipes can go from one pipe. I am making all of this. Now see, the process is almost the same. It's not exactly the same. So you bought in a machine and now you want to understand that if I want to make a certain kind of an elbow, so this kind of an elbow, a PVC elbow, where one pipe goes here, one pipe goes here, how long does it take for me to do this? When you went to buy this machine to make this elbow, the person who was selling you the machine said, whoever you put to work on this machine or whoever you hire should have a certain knowledge of the machine. So you say, okay, tell me what kind of knowledge. He said, number one, the person should be at least 30 years old and at max 50 years old, somewhere between the 30 to 50 bracket. Because this machine requires a certain sense of maturity to work and requires heavy lifting or heavy pulling of nozzles. So please make sure somebody between 30 to 50. Okay. Number two, to be able to work on this machine, you need to have basic knowledge of English. because there are these calibrations and readings that are written in English. Because of which, if you don't understand what they mean in English, you will not be able to understand them. So you need somebody who is fluent at English. The third thing that you are expecting from me is try and hire somebody who at least has worked on this machine for 3 years before. Okay. Now the problem is, I'm not starting work yet. I'm just trying to get an idea how long does it take to make one object. So will I immediately hire somebody new? No. I have ample workers in my factory. They've never done something like this before. But it's the same job, no? It's eventually making PVC pipes only. So what I do is, I pick up a guy and I ask him to keep making, let's say, 100 elbows. He made 100 elbows. And after making 100 elbows, I did a calculation and I realized that it takes an average of 10 minutes to make one elbow. Fantastic. But my question to you is, number one, is this person that you've hired, or is this person who has given you this average time of 10 minutes between the age of 30 to 50? Yes, he is. He's 34. Fantastic. Does the person understand English? He said no, he had a little bit of a problem with English. So the first few times he had to stop and very carefully look at the calibrations. Oh, so you are trying to tell me that if he knew English, he could have done it better. Yes. Fine. Then in the English section, I am putting a dash because he's not somebody who's learnt English. Does he have 3 years experience working on the same machine? No, never looked at a machine like this. It is because I asked him, he's looking at a machine. So dash. What I'm going to do now is, I'm going to performance rate this person. What do you mean by performance rate this person? Depending on what should be the person working on this. And what I have, I'm going to judge whether this person is at par or not at par. Well, this person who's doing it is not at par. Let's say at max I can say that this person is only 80% at par. So I am giving him a performance rating of 80%. Well, how is this helping me? Listen to what I am saying carefully. This person from your factory, let's say Sumit, did this over and over again 100 times and you got an average of 10 minutes. Can you say anybody who works on this machine will get 10 minutes? No. You know why? The person working on this machine is lot less equipped as compared to who I'm actually going to put on the machine. When I actually hire somebody to work on that machine, I'm going to put out a job description saying, I want somebody 30 to 50. I want somebody who understands English. I want somebody who has 3 years work experience. And when that person comes in, that person is going to be better than this person who did the job. So now listen to what I'm saying carefully. Again, even if you don't get what I'm trying to say, it's okay. Eventually, it's just formula application that is important. So, if this person is not as good, the actual person who comes there is going to be better. If that person is better, will that person take more time or less time than 10 minutes? Well, if he or she is better, will definitely take lesser time than 10 minutes. Sure. Then if he or she is going to take lesser time than 10 minutes, multiply the performance rating by the average time and you will get 10 into 80% and that is 8 minutes. And from observed time, I have an average time, and from the average time, I have something called as a normal time. What do you mean by a normal time? What I mean by a normal time is, if a normal person who is equipped to work on this machine does this job, it will take him or her 8 minutes, because the person from whom I got the work sampling done is not as good. Reverse in the Puri section. These people have been doing this for 10 years. These people have been doing this as a daily thing. Puris in our house are made once, not even once a month anymore in my house. It's only very special occasions. So it's probably once in a year or 2 times in a year. Can you compare the person doing something once in a year and somebody who's doing it every day or at least for around 300 days a year? You can't. There, I will give these people a performance rating of more than 100%, because they are better than the normal lot. This guy is not as good as the normal lot. They are better than the normal lot. So the average time is 1.5. Not a normal person will not take 1.5, will take a lot more than 1.5. If these people are, let's say, 140% efficient, then multiply the 1.5 by 140, because normal people will take more time. How much more time? We're already 100% of this time and another extra 40%. So 140% of 1.5 will be somewhere around, I think, 2.1. 140% of 1.5 minutes is 2.1 minutes. So a normal person can't do this in 1.5 minutes, will take more, because the people doing this are way better than normal. While in this case, the normal person who will work on this machine with this kind of a qualification will be better than this person, and that is why that person will take lesser time. And that is where we come to something called as normalizing the time. So I started off with a observed time. What is observed time? Observed time, that was time that I kept seeing over and over again. So observed time. So I have like 100 observed times. From the observed times, I did something called as an average time. I took an average of that time. This average was not enough, because was the person who was doing this study for you better than normal or worse than normal? Depending on that, you will have to adjust the average. If that person was better, then a normal person will take more time. If that person was worse, then a normal person will take less time. And that is why you normalize the average time. How do you find the average time? Well, you take all the observed times, add them up and divide them by the total number of readings. How you normalize the time? Well, what I basically did is I multiplied the average time by the performance rating given to that person. This person had an 80% performance rating, so his normal time was 10 minutes. I multiplied that and I said a normal person doing this job will not take 10 minutes, will take 8 minutes. While on the other hand, I had given these people a performance rating of 140% because they were like 40% better than normal people who do this job. And if they took 1.5 minutes, a normal person will take 2.1 minutes, which is how 1.5 into 140%. So this is nothing else but normal time is average time into the performance rating. And now we come to one last thing, and that is called a standard time. Now, why not work with a normal time? Well, because when you are studying someone like this person who is doing the job, if you ask him to make like 10 or 20 units for you, he will in full energy and full vigor do those 10 jobs for you. But when that person who actually works on this machine is going to come, he or she is going to have to do this for 9 hours straight of their working time. In those 9 hours, that person might have to sit down because they are tired of standing. That person's hand might start aching, so they might stop and they might just exercise the hand a little. That person might want to go use the washroom. That person might want to drink a little bit of water. That person might just want to wash his or her face and come back to freshen up. What you are not considering is that in this, when you ask them to do it 10 times, 20 times, they did it in full energy. But when somebody has to do this for a lifetime, there will be times when they get bored, they get tired. And that is where we come to something called as rest and fatigue allowance. What is rest and fatigue allowance? Rest is if the person wants to rest. Fatigue is if the person is tired, wants to take a break and then start work. Again, is a rest and fatigue allowance. So to this normal time, we give them a rest and fatigue allowance and say that we have reached a standard time. And what is standard time? Standard time is whatever your normal time is, multiply that by 1 plus the allowance factor. What do you mean by 1 plus the allowance factor? See, the allowance factor will be given to you as give them a 20% allowance factor. What does that mean? Whatever the time is, give them 20% extra just for rest and all the other things. So what you say is, if I'm giving 20% extra, am I not giving them 100 and, where do I write it? Am I not giving them basically 120%? So the original 100% time I'm going to give you. I'm going to give you a 20% extra. So isn't that basically your original time plus 20% is 0.2, which is 1.2. So am I not asking you to inflate your normal time into 1.2 times what it was originally? And that is why it is 1 plus the allowance factor. What do you have to do? If whatever I have said feels like too much, I could have said a lot more, but I want to stop here. If whatever I have said is too much, what we are doing is, whenever we are doing a new job, who does not have a standard time or who I don't know the standard time for, what I'm going to do is, I'm going to put somebody there and ask them to do it over and over and over and over and over again. Once I have, let's say, 50 times that the person has done that job, I'm going to average that time. That time, depending on what that person who was doing that job's performance rating is, I will multiply the average by the performance rating. And then I will standardize that time by multiplying the normal time by 1 plus whatever extra allowances that I will give that person. So observed time becomes average time by taking a sum of the observed time and dividing by n. That average time becomes normal time. How? By multiplying the average time by the performance rating given to that worker. And lastly, we come to standard time, and that is whatever normal time you got, multiply that by 1 plus the allowance factor. Now I just want to add one more thing here, and I will tell you when to use what. Right now, just humor me. There is another way of normalizing this time, standardizing normal time, and that is normal time divided by 1 minus the allowance factor. I will tell you when to use what. Right now, just remember there are two ways of inflating time. So let's quickly take an example and wind this up. I had a lot of observed times from which I took an average, and I realized that the average time to do this job is 5 minutes. Then I realized that the person doing this job had a performance rating of 90%. He was 10% short than the normal person who does this job. So I said that normal time is the average time into the performance rating, which is 5 into 90%, and 90% of 5 is 4.5 minutes. So a normal person who is equipped to do this job will take 4.5 minutes. Now I have to standard this time, and if you give me an allowance factor of, let's say, 15%, standard are 15 and 20, but whatever they give you, you take it. If they give you an allowance factor of 15%, you say that standard time is normal time into 1 plus the allowance factor, or standard time is normal time, which is 4.5 into 1 plus the allowance factor, which is 15%, which is 0.15, which is 4.5 into 1.15. What is 4.5 into 1.15? 4.5 into 1.15 is 5.175, or you could have done this also. 4.5, give it another 15% is 5.175. So the standard time to do this job is 5.1575 minutes. That's it. And now I can use this standard to calculate two things. Number one, what my capacity is. So in a day, if I run the unit for 6 hours, 8 hours or 10 hours, how many units can I make? So if I approximately say that this is 5 minutes to make calculations easier. So in 1 hour, I can make 12 units. In 10 hours, I can make 120 units, and that's my capacity. Another place where you can use this is if somebody comes to you tomorrow and they say, I want 50 units of this, or I want 100 units of this. How long will it take for you to make it? I will say there is already an order pending of 60 units. Once that is done, I can process yours, and yours is 100. Tomorrow's day is free. I can definitely give it to you by tomorrow evening. This you can tell them because you know the standard time of doing the job. If you would not have known the standard time of doing the job, this would not have been possible. So let's quickly go back as to how will you calculate the standard time to do a certain job. Well, this is how I reach a standard time. And that is, number one, establish a standard job method. So we've learned this. Develop a standard moment of doing the job, no matter which worker comes. You tell him कि देख ये right में ही खड़ा रह के डालना है, ये बैठ के ही करना है, ये उठ के ही करना है, whatever it is. This pedal has to be pushed while you are sitting down. This nozzle has to be held while you are standing up. Create a standard way of doing that job. Break down the job into elements. Like remember the puri thing that I told you? We broke it down into 4 elements. You do the same thing. Study the job. Rate the worker's performance. So study the job and understand what rating is required to do the job. And is that person doing the job equipped or not? If he or she is not as good as what I would expect a normal person to be, then give them a lower than 100 rating. If they are better than what I expect them to be, give them a more than 100 rating. Number 5, compute an average time. So you will have a lot of times because you will ask them to do this over and over again. In one cycle, I can't tell you what the average time will be. Maybe the first time they were still getting comfortable, they didn't didn't get to do it very fast, so they took a lot of time. Or maybe it could be that they got lucky that they did it so fast. So you have to do it over and over again to have a lot of observed times. You take an average of those times, compute a normal time, and normal time is your average time into the rating factor. So PF is performance rating, PRF is rating factor, PF is performance factor, whatever, it's the same. Or normal time is the element average time into the rating factor. Number 7, compute the standard time. Standard time is normal time into 1 plus the allowance factor, or standard time is normal time divided by 1 minus the allowance factor. So remember this question, this example that I did for you. Let me show you that both these methods don't give you a very different answer. Like for example, average time, average given a performance rating made it normal. Normal is made standard. What if I would have used the other formula? That standard time is normal time divided by 1 minus the allowance factor. You would have almost gotten the same answer. So it is 4.5 divided by 1 minus 0.15. So 1 minus 0.15 is, I don't have place, so I'm doing it directly. 1 minus 0.15 is 0.85. So it is 4.5 divided by 0.85. So the answer is 5.29. So here I approximately get an answer of 5.2. Here I approximately get an answer of 5.3. So it's just like 0.3 seconds here and there. 0.1 second here and there. Not much of a difference. When to use which formula? I will tell you. And this is time and motion study. We've almost finished an hour only talking. So let me do a quick recap. What is time and motion study? Whenever we are doing something for the first time, we don't know what standards they produce in. If it is something that produces this water bottle, I don't know how long it takes to make one water bottle. So I can't tell you how many water bottles can I make in a day. So if I want to understand my capacity, number one, and number two, if I am producing 50 bottles a day, is it good? Is it not good? Is it better than the standard? All this I don't know, and that is why we need to do a time and motion study to develop a standard time to do something and a standard motion to do something. What do? You ask somebody to do the jobs over and over again. You performance rate them. After doing that, you will have a lot of observed times. You take an average and make an average time. After taking an average time, you multiply the average time by the performance rating, and that will be the normal time. After doing a normal time, you standardize the normal time by doing a 1 plus allowance factor or divided by a 1 minus allowance factor. Either of the two formulas give you almost the same answer. Where to use what, I will tell you when we do questions. Now, because your institute material, like I said, keeps doing these things, they have removed all. They were like very good, around 15 to 20 questions in this section. They've removed all of them and they've only kept 4. So we are going to do only those 4 questions. But those 4 will not be a very easy 4. They will require a knowledge of a lot of other things. So like I did in the incentive bonus question, where I showed you how this question can be done if that unmeasured work was not given, and then when measured work and unmeasured is given. That is what I did with that question. So we will do something similar whenever I think that there is some extra knowledge of some basic question that is required. We will eliminate a few things from the question and try to study them by ourselves normally and then implement that extra factor. So let's begin with questions. This is the first question that I want to discuss, and I want to discuss because it's a very typical question. It was a very beautiful question. I don't know why your institute material decided to omit the question. So this question was there in the 2008 syllabus, and it was also carried in the 2012 syllabus. So what does the question say? A stopwatch study figure for a job which is continuous in nature. So the stopwatch is continuous. I'll tell you what it means. Given below, calculate the standard time for the job assuming that a sample size is adequate and that allowances are 15%. So stopwatch study, okay. Continuous stopwatch study. I'll tell you what that means when we look at values. Calculate the standard time for the job assuming the sample size is adequate. What are you doing? Depending on these 10 cycles, you are going to decide the standard time to do this job. Are you sure only 10 cycles are enough? That is what they are saying. Assume that this sample size of 10 or doing this 10 times is enough for this job to get a standard time out of. And allowances. So do you see the word allowances, which is the allowance factor? Is 15%. Okay, one thing at a time. So there are 4 elements, A, B, C, D. So what that person has done is, he or she was holding a stopwatch. Whenever the person doing that job started doing A, they started the watch. They stopped and B started, they did lap. So what you notice here is that, here, A stopped at 0.10, which means to do A once It took 0.10 minutes. What about B? It took 0.17. That's wrong. It's a continuous stopwatch study. So if you notice, the time keeps increasing. 0.10, 0.17, 0.29, 0.42, 0.05, 0.57, 0.68, 0.81, 0.90, 0.96, 0.08, 0.2, 1.22. What does that mean? That they've just kept pressing lap and the time has gotten recorded. How do I find the actual time to do that job? Well, I'll tell you. See, from 0 to 0.10 it took to do A. Correct? Correct. Then the time taken to do A for the first time is 0.10. Nothing wrong with it. B started after 1.10 and went up till 0.17. Which means B didn't take 0.17 minutes. It took the extra after 10. How much extra? 7 extra. And that you have it here. 0.07. Next, at 0.17, B ended and C ended at 0.29. So how much time did it take to do C? 0.29 minus 0.17, which I think should be 12 roughly. So it should be 0.12, correct? 0.12. How much time did it take to do, sorry, this should not be B, this should be D, to do D? From 0.29 to 0.42. From 0.29 to 0.42, 0.42 minus 0.29 is 0.13. That's the difference between them. Is it 0.13? Yes. How long does it take to do 2 or A for the second time? Well, see, D ended in the first cycle at 0.42 and then A started again. So at 0.42, D ended. And at 0.50, A ended again. So the difference between them should be 0.8. Let's check. Yes, it takes 0.08 minutes to do A in the second cycle. So from the continuous, basically this is cumulative time. From the continuous cumulative time, I find out the individual timings. What do you do after you have the individual timings? After I have the individual timings, I have my observed times. Step 2 is now going to be averaging these observed times, because I can't work with 10 different times. Give me one single average. And that is why I take the average time to do A, the average time to do B, the average time to do C, and the average time to do D. After doing that, the person who does A has been given a performance rating of 90%. He is less than normal. Person doing B has been given a performance rating of 110%. Person doing C is given a performance rating of 120%. And person doing D is being given a performance rating of 100%. So I will multiply them by the performance rating and then normalize the average time. So it is going to be 0.09 into 90% is 0.081. 0.068 into 110% is going to be 0.075. 0.118 into 120% is 0.142. And 0.128 into 100% is 0.128. Once I have normalized the time, and remember one thing, if everybody's performance rating was the same, then I would take a total of the average time and apply performance rating only once. Because everybody's performance rating is different, I apply the performance ratings and then I take a total. So what is my total normal time? My total normal time to do this job once is 0.426 minutes. Now I have to standardize this time by how much? By a 15% allowance factor. So what I'm going to say is, I'm going to say standard time is normal time divided by 1 minus the allowance factor. Why 1 minus? I will tell you. The answer is 0.501 minutes. So to do this job once, which is to finish A, B, C, D once, it takes 0.5 minutes or it takes half a minute. That's my answer. So, observed becomes average, average becomes normal, normal becomes standard. That is all you need to do. On similar lines, I have put in another question, which is a question from again the 2008 syllabus, but I put this now for a slightly different reason, and I'll tell you why. Why I have put this question. Let's start reading from the top. An analyst has observed the job long enough to become familiar with it and has divided into 5 elements. Our previous job was divided into 4 elements. This one is divided into 5 elements. The element times for the first 4 cycles and the performance ratings for each element are given in the table below. So, you divided the job into 4 parts. Every part was done by a different person, or every job could be done by the same person, and the same person has different levels of doing different parts of the job. Some parts he is very good at, some parts he is very bad at. Fine. Now here they never said that it's a continuous stopwatch study. That is why this time is a normally recorded time to do that element in that cycle. So when I do 1 for the first time, it took 1.246 minutes. Then when I do 1 for the second time, it took 1.328 minutes. Obviously somewhere around, somewhere less or more. When I did 1 again for the third time, it took 1.298 minutes. And when I did 1 again for the fourth time, it took 1.306 minutes. The performance rating for the person who did 1 is 90%. So I understand the table now. What is your question? Do any of the times look like outliners, that is, probable errors in reading or recording data that should not be included in the analysis? What? Do any of the time look like outliners? What do you mean by outliner? See, when I did 1 for the first time, it took 1.2, next time 1.3, next time 1.2, next time 1.3. So somewhere in the 1.2, 1.3 bracket. 1.1 was also okay, 1 was also okay, 1.4, 1.5 was also okay. But everything is in place. Let's go to doing 2. First time 0.97, second time 0.89, third time 0.79, last time 0.919. Perfect. So it is somewhere around the 0.7 to 0.9 bracket. Fantastic. 3 when I did for the first time, it took 0.914. For the second time, it took 1.875. It almost took double the time that it took for the first time. In the third time, it took 1.964. In the fourth cycle, it took 1.972. But there's something wrong. If it's taking 1.8, 1.9, 1.9, how come it took only 0.914? This could be an error in recording. And if this is an error in recording, I can't correct it now because I don't know. This could be 1.914, but it's not my job to correct it. If it's wrong, it's wrong. Wrong data is garbage. We do not consider wrong data. Then this 0.914 will not be considered in estimating the time for element 3 because it looks like a probable error in reading or recording data. Let's continue and check for everyone then. So, for element 4, 2.1 perfect, 2.1 perfect, 2.1 perfect, 2.4. That's okay. In a decimal here and there shift, no problem. 1.2, okay. 1.1, okay. 1.4, okay. 2.2, that's too far away. Something is wrong. So, I think or I see 2 probable errors. Let's look at the solution. Well, the solution says that the times for element 3 in cycle 1. Element 3 in cycle 1, yes, is wrong. And for element 5 in cycle 4. For element 5 in cycle 4, yes, are suspect and should be disregarded. So these could be wrong timings and they should be disregarded. Once that is done, what is the second question? Compute an estimated normal time for the job based on the data available at this stage of the study. So you want me to only get you a normal time? Yes. Okay, I will give you a normal time. Because anyway, if you read the question, they have not given you the allowance factor anywhere. Okay, then I will only normalize the time for you. Number one, I will take the averages for 1, averages for 2, averages for 3. But remember, don't consider this in the average. Only consider these 3 values. Add these 3 and divide by 3. Add these 4 and divide by 4. That is okay. Here also add the 3 only and divide by 3. So once you have an average, then you multiply it by the rating factor and you normalize it. Take a total, and the normal time to do the job is 7.723 minutes. That's your answer. Like I said, I'm only discussing these because they are not a part of your syllabus. Let's now come to the main question that start in your institute material. And that is the first question, which is on page 165, question 7. A very basic question. Calculate the standard production per shift of 8 hours. Okay, I will tell you what the standard production for per shift of 8 hours is with the following data. Observed time is 5 minutes. Oh, which means you haven't found the standard time. I should find the standard time and then the standard production in 8 hours. Okay. So I have observed that it takes per unit 5 minutes. With a rating factor of 120%, and the total allowances are 30% of normal time. Pay attention to the word of normal time. Whenever they write something like of normal time, you have to use the 1 plus allowance factor formula. Let me minimize this for you. Let me bring out the same question. So, calculate a standard time. Here, let's begin. So, you want me to find out what the standard production in an 8-hour shift should be. And then give me the standard time per unit. I will tell you what the standard production should be. You haven't done that. What you've done is, you have given me an observed time. And if you notice, technically I expect you to at least give me 5 or 10 observed times. You've just given me 1. But that's okay. That's all I will work with. So for me, average time and observed time will be the same. What is the rating factor given to this person? Well, the rating factor, the performance rating given is 120%. Allowances that you are given the person. So allowances are 30%. And what is very important is they have written of normal time. Whenever they write the word of normal time, the standard time formula that you will use is normal time into 1 plus the allowance factor. Always remember this. So I don't have an average time. I only have an observed time. So I will directly start with normal time is observed time into the rating factor, or normal time is observed time is 5 minutes into the rating factor is 120%. 120% of 5 is 100% is 5 and 20% is 1. So it is 5 plus 1, which is 6 minutes. Normal time is 6 minutes. Standard time is normal time into 1 plus the allowance factor. So standard time is normal time, which is 6 into 1 plus. Allowance factor is 30%, which is 6 into 1.3. 1.3 into 6 is 7.8. So the standard time to do this job is 7.8 minutes. But I didn't ask you the standard time. I asked you the standard production in an 8-hour shift. Oh, okay, 1 minute. 8 hours per shift is basically 8 into 60 minutes per shift. 6 8s are 480 minutes in one shift. Well, if you understand, it's 480 divided by 7.8. If you don't, go back to school. No shame in it. One unit takes 7.8 minutes. Then X units can be made in 480 minutes. Cross multiply. X will be 480 divided by 7.8. What is 480 divided by 7.8? The answer is 61.53. So the number of units that you will make is 61.53. On a standard basis where I learned production and I learned management, you cannot make 61.53 units. That half a unit is not made. So the article is not made. So we say 61 units. Let's quickly come to your institute material and see what they have to say. So, normal time per unit is observed time into the rating factor, which is 5 into 120 upon 100, which is 6 minutes. Allowances are 30%. 30% of 60 is 1.8 minutes. Standard time is normal time plus the allowances. So 1.8 minute is the allowance. So your final answer is 7.8. So ignore all this. Remember how I have gotten you the answer. So it takes 7.8 minutes to make per unit, which if I convert for 8 hours, in 8 hours you will make 61.54 units. And that's your answer. Let's come to the second question. The table is a tad bit large. Let me unzoom. So this question is question number 2 in my sheet. It is page 165 in your institute material, question number 8. And the question says that study in a packaging department of a soft drink manufacturing unit revealed the following facts for a worker, Basantrao Patil. So Mr. Basantrao Patil is being watched and they are trying to understand Basantrao Patil's work, and they are trying to understand Basantrao Patil working in the packaging department. So they are trying to understand how does the packaging department of a software firm work. Fine. Cycle. So I am doing this 4 times, 4 cycles. What are the activities? I have divided the activities into 4 parts. Number 1, get a cartoon, empty cartoon. Empty cartoon is an empty box. Place the bottles in the cartoon. Then suppose that box has a capacity of 12 bottles. So you pick up and you put the 12 bottles. Done. C is you close the cartoon and set it aside. So done. Cartoon is closed. Stick it, set it aside. Now what? Now go back to A. No, 1 minute. There is smoking also involved. No, he's not smoking now. He's smoking in the second cycle. So what did he do? Picked up an empty cartoon, took 0.15 minutes. He placed the bottles, took around 1.5 minutes. Then he sealed the cartoon, or basically closed it and put a sellotape probably on it, and took 0.2 minutes. Then he didn't smoke, he went to again A. Now this time when he brought an empty cartoon, it took 0.25 minutes, took slightly more. And then there is a star. What is this star? They've given you a description right below. And they said that bottle slipped out of hand and broke. So see, the bottle broke. Now breaking of the bottle is not a part of the job. Now he broke the bottle, everything was wet. So now he had to clean it. So what I did is, I said don't consider this reading. After that they put a plus sign in the next one also. What did they say? Empty cartoon not set aside and used for packaging in the next cycle. Now you agree that he broke the bottle here. So then the packaging wasn't done. So what they said is, don't consider the setting aside of the cartoon also. Use this cartoon in the next cycle. And that is why in the next cycle, we don't have getting an empty cartoon, because he is using the same cartoon that he brought here. Because the bottle broke, he didn't do the rest of the 2 things. So he's using the same cartoon in the next cycle. So we again start, he bought 30 fresh bottles, placed them into the cartoon, sealed the cartoon, pushed it aside. Then he again did the same. Now here, when the bottle slipped out of his hand and it fell. There is a star and a plus. And after that, so probably the bottle broke, he cleaned it. He didn't have to seal the cartoon because that cycle was not considered. He decided to go smoking. Now, since smoking is put as a part D, am I going to consider smoking in my analysis? No. If I have a worker who does this job twice and then the third time I'm going to tell him, my old previous worker used to smoke after the second cycle. Why don't you also smoke? He'll say, no sir, I don't smoke. No. It's a part of my working. It's not a part of your working. So you will not consider the smoking as a part of your cycle. And these are the unwanted jobs or unwanted movements that we are talking about. Smoking. This is the second job. General conversations is another job. These are the things that we have to cut out of the motion. So we will not use those to generating a standard time. So I have 4 cycles, out of which technically if you go to see, one cycle I am not going to consider, which is B2, C2 and A3. I am not going to consider. So basically one cycle is gone, so I am only going to consider 3 cycles. Fine, what do you want me to do? The bottom of the question says, calculate the standard production by Basant Rao in a shift of 8 hours when the unit standard rules allow 50% as allowance factor. I want you to pay attention to 10% as allowance factor and remember it. That's all I want you to do. So what I'm going to do is I'm going to first draw the table so that I have it in front of me when I'm doing the question. So these are my cycles and these are my elements and these are my cycles and these are the cycle timings. I have written D also, but I will not consider D in my analysis. And if you notice, they haven't given you this for D also, which is D smoking will not have a rating factor. How good a smoker you are, how bad a smoker you are, none of my business. You do my work is the only thing I care about. So the next thing that I'm going to do, I'm going to do the question in this table only. You can do it separately. I'm doing it here. My observed time will have to be averaged. So I'm going to find an average time. And that average time will have to be normalized. So I'm going to draw a normal time. Correct? So number 1, average time. How am I going to find average time? Well, here add the 3, divide by 3. So 0.15 plus 0.25 plus 0.17. Divide that by 3. The answer is 0.19. So 0.19 is the average for A. For B, the average is 1.56 plus 1.80 plus 1.75. 5.11 divide that by 3 is 1.7033333. So I'm writing 1.70 only. And lastly, I have 0.20, 0.10, 0.15 is 0.45. Divide that by 3 is 0.15. This is going to be dash. I'm not going to consider it. Let's normalize the average time. How? By multiplying it by the performance rating. So 0.19 into 90%. The answer is 0.171. 1.703333. So 1.703333 into 105% is 1.788. Can I say that is approximately 1.79? Next, 0.15, 95%. 0.15 into 95%. The answer is 0.1425. So 0.1425. Done all the normals. Take a total of the normals plus 1.79 plus 1.171. The answer is 3.1035 is the normal time. Now, if you look at the way in which the allowance is given, they say 10% as allowance factor. Did they say of normal time? No. They said 10% as allowance factor. If they said that, then the formula you will use is the divide by 1 minus the allowance factor. So standard time is normal time divided by 1 minus the allowance factor. So remember this, when they say of normal time, you use the 1 plus formula. When they say allowances are, then you would use the 1 minus formula. So standard time is 3.1035 divided by 10% allowance. 10% is 0.1, which is 3.1035 divided by 0.9. Your answer is 3.448, which is, can I say, approximately 3.45. So it is 3.45 minutes is the standard time taken by Basant Rao to pack one cartoon. I'm sorry, I think I seem to have made a mistake in the addition. Let me check that quickly. 0.171 plus 1.79 plus 0.1425 is, sorry, it is 2.1035. It is 2.1035. So it is 2.1035 divided by 0.9, and the answer is 2.33722 and so on, which is approximately 2.34. I'm sorry about that, my sum was wrong. So the standard time taken by Basant Rao to pack one cartoon is 2.3372 minutes, which I approximated to 2.34 minutes. What are you expecting out of me? Well, what you are expecting out of me is, you are asking me that calculate the standard production by Basant Rao in a shift of 8 hours. Okay, so similar like the previous question, I have a standard time now. So I am going to say one cartoon takes 2.34 minutes. Then X cartoons take 8 hours, which is 480 minutes. Cross multiply. X is 480 divided by 2.34, which is 480 divided by 2.34 is going to be 205.128 cartoons, which according to me is approximately 205 cartoons. So in a shift of 8 hours, Basant Rao will have packed 205 cartoons. Let's quickly look at their solution so that we can move on to the next question. And their solution is, to begin with, number 1, they have not done this in a table. They have directly calculated the average using basic. So element A, add the 3, divide by 3. 0.19, same. Element B, 0.1703, correct. And element number 4, which is 0.15. So they've, all 3 is correct. The only thing is this, they have taken up till 3 decimals. I haven't. That's fine. A little fluctuation here in the 3rd or 4th place is okay. Now they drew a table. Average, performance rating, normalize. Normal total is 2.101. My normal total is 2.103. When the normal time is standardized, it is 2.334. Well, mine is also the same, 2.334. I made that 2.3 2.34. And then they took a standard, they got an answer of 205.66 cartoons. I got an answer of 205.128 cartoons. That's okay, a little decimal shift, because depends on how many decimals that you are taking. If you want to take up till 3 decimals, then the answer will shift, but approximately the answer is the same, 205 cartoons. That is it. That was question number 2. The next question that I want to do is, I want to skip 3, come to 4, do 4 first and then go back to 3. And the question says, it's a slightly different question, so pay attention. Calculate the standard time per unit produced from the following data. Fantastic. They want you to find the standard time that it takes to produce a certain number of units. Okay. Total observations is 2597. Number of working observations is 2000. Now this is something odd. Number of objects produced in 100-hour duration is 5000. This is something which is relevant data. That in 100 hours, you have produced 5000 objects. Fantastic. Proportion of man labor is 3/4. Okay, now this is new. Proportion of machine labor is 1/4. Observed rating factor. Fantastic rating factor I require. And allowances are 15% of normal time. Okay. Now what I will do is, because I can't keep the question, I will write down the particulars and then we'll begin with the question. I have the data ready. Let's start the question. So let me do one thing. I'm going to, like I said, I'm not going to do what the question says. I'm going to only pick up whatever I want or whatever I understand from the question and only do that. And then keep adding one complication at a time. Total number of observations, 2597, I don't understand. Number of working observations, I don't understand. I don't want that data. Well, what you've done is, you've done the study for 100 hours and in 100 hours, 5000 units were made. Fantastic. I will get the average time from that. How? I will say 100 hours is 100 into 60, which is 6000 minutes. Correct? So I will say 5000 units are produced in 6000 minutes. Then to produce 1 unit, how many minutes do I require? X goes here, 5000 comes here. X is 6000 divided by 5000, which is 0, 0, 0, 0 cancels. It's 1.2. Anyway, 6000 divided by 5000 is 1.2. So on an average, then to make 1 unit, it took 1.2 minutes. Or in other words, my average time is 1.2 minutes. Fantastic. You have your average. Fine. Average can be normalized by giving it a performance rating of 120%. Yes. So I will say 1.2 minutes when given a performance rating of 120% is going to be normal time is average time into the performance rating, which is 1.2 into 120%. 12 12s are 144, which is 1.44 minutes. So the normal time to do this job is 1.44 minutes. And then I need to standardize. How will I standardize? With the allowance factor. The allowances are 15% of normal time. Then I'm going to say standard time is normal time into 1 plus the allowance factor. So standard time is normal time. What is your normal time? 1.44 minutes into 1 plus the allowance factor. The allowance factor is 15%. So 1 plus 0.15, which in other words is 1.44 into 1.15, and that is 1.44 into 1.15. So the answer is 1.656 minutes is the standard time to do this job. Is that correct? That's terribly wrong. But this is what I usually do. Correct? Now I will add one complication at a time about what they are saying. Complication number 1. Let's start with total number of observations is 2597 and number of working observations is 2000. What do you mean by that? Well, this is what you mean. This job that you are doing for me, whatever the job is, like for example, Mr. Basant Rao putting the cartoons together or putting the bottles in the cartoons. Can I say that to put the bottles in the cartoons, I need cartoons? To seal the box, I need sellotape. What if the cartoons and the sellotape are empty or not available? Well, he will have to go to the storage area or talk to his manager, go wherever he has to, and then sign and then bring the cartoons to the store first. Or remember the measured work, unmeasured work condition. What happens is, in that entire 100 hours, I observed you 2597 times. So I came to the shop, I checked what you are doing. Oh, he's packing bottles. Let's go back. I came to the shop, he was not available. So I went back. I came to the shop, he was smoking. So I wrote he was not working. I came to the shop, he was working. Fantastic. I came to the shop, he had broken a bottle. So he was cleaning it, again not working. So I observed him for 2597 times. In these 2597 times, he was working for 2000 times. The rest of the 597 times, he was not doing the designated work. He could be working, he could be sweeping the floor. That is also a job, but that's not a job that I am studying right now. He could be smoking. That is not the job I am studying right now. He could have gone to the floor manager to talk to the floor manager about something. That is not my job. If he was not doing my job, I am going to put that visit under not working. So in the total 2597 times that I tried to observe him, he was working for only 2000 times. The rest of the 597 times he was not working. Or in other words, can I say the total 100 hours that are clocked in, he was not working for all the 100 hours? And that is why I am going to change the solution according to a new entry of data. And the new entry of data is, the new entry of data is that the ratio in which he was working, which is he was working for 2595 times I observed him, in which only 2000 times he was working. Then how will I find out of 100 hours how many hours was he working? Simple. Out of total 2000 was working. Then out of a total of 100 hours, let him be working for X hours. Out of 2597 observations, 2000 were working. Then out of the total of 100 hours of observations, how many hours was he working? Cross multiply. X is equal to 2000 divided by 2597 into 100. Or I'll give you another basic way of doing it. The ratio of work should be equal to the ratio of time. What is the ratio of work? The ratio of work is 2000 out of 2597 observations. It should be same as the hours that he was working against the total hours, which if you cross multiply, you will again get the same, and I'm writing it here because I don't want to waste place. X is equal to 2000 upon 2597 into 100. Let's quickly do that then. 2000 into 100 divided by 2597 is this. So he was working for 77.01193 hours out of the total of 100. If this is the number of hours, what is the number of minutes that he was working? Well, multiply that by 60 and he was working for 46271 minutes, or approximately, if I approximate this, it will be 46207.72 minutes. So 4620.72 minutes. Let me repeat this. Initially, when they said that in 100 hours he makes 5,000 units, I directly said fantastic. 100 hours is 6,000 minutes. In 6,000 minutes, he's made 500 units. So 1 unit took 1.2 minutes. That changed. How did that change? Well, what changed is that, what I don't realize is that all the time he's not only doing that one job, you're doing other things also. So how many times is he doing my thing? 2,000 times. Out of what? Out of a total of 2597 jobs. So the time taken to make those 5,000 units is not 100 hours, out of which some part he was not doing that work. So for what fraction was he doing that work? Simple. The fraction of observation should be equal to the fraction of time. So he was doing your job 77 hours out of the total 100, which is 23 hours. Sorry, 23 hours he was doing something else. Which means for 4620.72 minutes, he was doing your job. Initially, you were assuming that for 6,000 minutes he is doing your job. No, he's not. He's only doing your job for 4620.72 minutes. And now continue. Now continue what? Now say that he is making 5,000 units in a total of 4620.72 minutes. Then he will make 1 unit in how many minutes? Cross multiply. X is 4620.72 divided by 5,000. X is 0.9241. Hasn't the time taken to do the job reduced? Obviously, because you realize that he's not doing my job for 100 hours. So those 5,000 units didn't take 100 hours. They took less than 100 hours. So if they took less than 100 hours, the average time will be less than the average that we got, which is 1.2. The average is 0.9241. Done? The average is 0.9241. Finish then. Average time 0.9241 minutes. I will make it normal time, which is 0.9241 into 120%. So multiply that by the rating factor, which is 120%, and you will get 11.0897 minutes is the normal time. Normal time can be standardized by multiplying the normal time by 1 plus the allowance factor. Why 1 plus? Because they clearly said of normal time. That is why the 1 plus formula. Standard time is 11.0897 into 1 plus the allowance factor, which is 0.15. Standard time is, increment this by another 15%, and the answer is 12.7531. And this should be your standard time to do the job. Is that correct? But this is still wrong, because there's still one more thing that I haven't considered. So let me quickly run through what I did. I initially said in 100 minutes, he's making 5,000 units. So for 1 unit, on an average, 1.2 minutes. But then this is average time, has to be normalized. So I multiplied the average time by the performance rating. I normalized it. I multiplied the normal time by 1 plus the allowance factor, and I standardized it. But then I realized that that is not how the question goes, because what they are saying is all 100 hours, they are not doing your job. They are doing other jobs also. Like for example, if you are a mechanic working in a mechanic workshop, in a garage, it is not always that you are always repairing cars. There are other things to do. There is cleaning up the garage. There is, if there is an oil spill, removing the oil, buying stuff for the repair. So if you don't have all the things, you make a list and then you go and you buy. So is it always that in an 8-hour day you will always be repairing cars? No. There will be a fraction of time when you will be doing other jobs. So those jobs I will not consider in if I am trying to study the average time to repair a car. And that is why I say that if out of 2597, 2000 times he was doing my job, which means, out of 100 for X minutes he was doing my job. So he was doing my job for 77 hours, which is roughly 4620.72 minutes. So now I have the time for which he was doing my job. Out of 5000 units, he took, to make 5000 units, he took 4620.72 minutes, which means to make 1 unit, he took 0.9241 units. I have the average. I will normalize the average by multiplying it by the rating factor, and then I will standardize the average by multiplying it by 1 plus the allowance factor. Done. Let's then come to the last leg of the question and finish this off. And the last leg is that what they've written here is that whatever equipment you are making, that equipment requires 3/4 time for a man to work and 1/4 time for a machine to work. What does that mean? What it means is that whatever job I'm doing, some part of that job was done by a man and some part was done by a machine. Not the entire thing was done by man. So if the job took 4 minutes, in those 4 minutes, 3 minutes a man was working, 1 minute the machine was working. So let's say if it is making this bottle, then I am setting up the heat, I am pressing the start button and all of that. Once that is done, the machine will work for 1 minute. After 1 minute, the machine will stop. It will open it up. I will remove the bottle, cut whatever has to be cut, and I will keep the bottle on one side. So in the making of the bottle, it's not 100% automated. Some part man is working, some part machine is working. So if the job takes 40 minutes, 30 minutes a man has to work and 10 minutes a machine has to work. That is how the ratio splits. And that is why I will have to go back. And this is how I'm actually going to solve the question. Number one, I'm going to say that if you are telling me that the job is done for 100 hours, all 100 hours you are not doing my work. If this was not given, I would consider that for all 100 hours you are doing my work. But here you've clearly noticed that in a total of 2597 times that you were observed, 2000 times you were doing my work, rest of the times you were doing other work. So for all 100 hours you were not doing my work, you were doing my work at. So time of attended work is 2000 out of the 2597 into 100, which is 100 hours, which is, or you can convert to minutes also and do it. So is going to be 2000 multiplied by the 100 and divided by the 2597. So attended work was for 77.011936 hours, which is how many minutes? Multiply that by 60, no? You will know minutes, which is 4620.7162 minutes. So I'm approximately saying that it is 4620.72 minutes. Fine. So let's go back and say what? And say that 5000 units were produced in 4620.72 minutes. Then to produce 1 unit, how many minutes will I take? Cross multiply. The time taken to make 1 unit is 4620.72 divided by 5000, which is 0.9241. So I'm writing it as 0.924. If you want to write the one, write the one. I'm writing 0.924 minutes. So the average time it takes to make 1 unit is 0.924. Now let's come to the next understanding. And the next understanding is that this 0.924 minutes that it takes, in this 0.924 minutes, 3/4 time man is working and 1/4 time machine is working. So I am going to say that in the 0.924 minutes, a man has to work for 3/4 of the time and a machine has to work for 1/4 of the time. So if you want to know for how long does a man work, then push this into 3/4 parts. So divide this by 4 and multiply it by 3. So 0.924 divided by 4 multiplied by 3. The answer is 0.693 minutes a man works, and whatever is left, what will be left? 0.924 divided by 4 is 0.231 minutes the machine works. Sir, okay, but why are we doing this? Be patient, I'll tell you. Let me quickly run through and then I'll tell you. The total number of times I've observed you is 2597, in which 2000 times you were doing my job, rest of the times you were doing something that I didn't care for. Which means in the total 100 hours that I gave you, you were not doing my work for all 100 hours. So I need to know that work that I had given you was given how many dedicated hours. Well, to find that out, I will say time of attended work is the ratio in which the work was done into 100, which means it is 77 hours, which means it is 4620 minutes, which means the 5000 units were not made in 100 hours, which is 6000 minutes. They were made in 4620 minutes. If 5000 units were made in 4620 minutes, how much time did it take to make 1 unit? Well, it took 0.924 minutes per unit. This 0.924 minutes that it took to make per unit is split into 2 types of work. 3/4 time a man is working, 1/4 time a machine is working. So I split the time into 3/4 and 1/4. The total should be 0.924. What's the point of doing this? I will tell you. Suppose at home you are baking a cake. Okay, 2 scenarios. You are baking a cake and whoever cooks at home every day is baking a cake. Now, the recipe says that all this has to be mixed and then the cake has to go into the oven for 1.5 hours at so and so degrees. Now, if you are doing this, which you have never done before, so you know what you start with? Number 1, aate ka dabba kidhar hai? So the first thing you do is you go to your mother, specifically in my case mother, and then you say, आटे का डब्बा किधर है? Then it all starts with तुझं कशातच लक्ष नसतं, घरात डब्बे कुठे आहेत तुला माहिती नाही, and then there is like a half an hour lost about how you have no interest in what happens in the house, and then you get the aate ka dabba. That is how lost you are in the kitchen. So obviously, if getting the batter ready takes you 2 hours, it won't take your mother 2 hours. It will take your mother a lot less than 2 hours. Because she knows what everywhere is, plus she knows how to mix it well. So that time will vary. Now comes putting the cake into the microwave or in the oven. The recipe says put the cake in the oven for 1.5 hours. Now if your mother puts the cake into the microwave, your mother is very good at this. So the microwave will make the cake faster, no? As compared to what you will. When you put the cake, the microwave will take longer because you are doing this for the first time. It's nothing like that. No matter who preps up, if the microwave takes 1.5 hours to bake the cake, it will bake the cake in 1.5 hours. No matter who is doing the work. If ice takes 30 minutes to get ready, or if ice cream takes 30 minutes to freeze in the fridge, no matter who makes the ice cream, the fridge will take half an hour only. What I am trying to say is, after this, we normalize the time, we standardize the time. Yes. Why? You normalize it because the man who's doing it is being given a certain performance rating, and I have to normal it to a normal person. 1 minute. Machines don't have performance ratings. Machines work on standards only. No matter what oven, who is baking, the oven will take 1.5 hours only. The oven will not change time according to who is baking. If you are baking, put it for 2 hours. If you are baking, put it for 1.5 hours. If you put it for longer, your cake is going to burn. That's it. If your cake is uncooked in 1.5 hours, that's your fault. You didn't make the batter properly. But the cake should be cooked in 1.5 hours is a standard time on the machine. Machines do not require normalization. Machines do not require standardization. So now when you apply the rating factor, now when you apply the standardization, machines don't get tired. The oven won't say, 1 minute, mera zara haath dard de raha hai, thodi der ruk jao. The microwave is not going to say that. The man might say that. And that is why this performance rating and the allowances are only and only given to the man and not the machine. So this now is my average time, which I will normalize by doing a average time into the performance rating, which is 0.693 into the 120%. 0.693 into the 120% is going to be 0.8316. And after this, I will standardize this time and say standard time is normal time into 1 plus the allowance factor, which is 0.8316 into 1 plus 0.15, which is plus another 15%. And the answer is 0.95634. Done. You split the time. You found out how long the man has to work. You normalize the man. You standardize the man. Now bring them both together. Now add the two and you will have your total time. And that is why we split it. We split it because the machine factor does not require normalization, does not require standardization. And I hope that you've understood it well. Add the 0.231 to it, and the average time to do this job is the standard time to do this job is 1.18734. So you can actually write it as 1.187 minutes. Let me quickly go to the material and see what they have done. Let's start with actual working time duration 100 hours, but attended work is 77.01 hours, which I showed you how. If they've not written the calculation in complete detail, that's okay. I have written it for you, so don't worry. Time taken, and that is why I say even if your institute material has all the solutions, make sure you create your own solution, because there are times. See, this is written in the institute. No, then this will always be there with you. You create your own solution by writing small things which you did not understand first, but then you understood after explanation. So write that down, because we are going to do around 15 concepts. Every small concept needs to register well, and there might be times when later you might forget something, and that is why you have to come back and look at what is done. That is why your book needs to be self-explanatory whenever you come back to study. Anyway, so in the 77 hours, when you make 5,000 units, they've directly multiplied by 60 and converted it to hours, you get 0.924 minutes. Perfect. I also have the same. This is split in man as 3/4 and machine as 1/4. So man requires 0.693 minutes while machine requires 0.231 minutes. Now, normalizing will only be done on man time. Correct? Standardizing will only be done on man time. The machine time remains as and how it is. Eventually, when you have that, you add it to the machine, which is 0.231 minutes, and that's your answer, 1.19 minutes. So they've approximated the 7 and written as 1.19. Either way it is okay. This is their solution, short and sweet and like 6 lines. This is my solution. I'm going to keep it up for like a few seconds so that you have the entire thing in front of you. So this is the first part. You can pause and then write it down. And this is the second part. And the answer is 1.8734, which is approximately 1.19. That is it. That is question number 4. We go back to 3 and put the final nail into the coffin. Let's come to the last question. It is exactly the same as the 4th question that we did, but with a slight change and an extra question. And I'll tell you what that is. This is the question. The following results are recorded in a study of work sampling. So what are you doing? You are taking samples of work. Basically, people are working. You are noting down a part of that work for 100 hours in a machine shop. Total number of observations recorded. So total number of how many times have I observed people in these 100 hours? 2,500 times. Now they've done something very sneaky here. Number of observations in which no working activity was noticed. What do you mean by no working activity? 400 times there was work that was not being done. In the previous question or in the question after this, they told you how many times work was being done. Here they have told you how many times work was not being done. 400 times work was not being done. So if 400 times work was not being done, we are not that dumb to understand this. Then 2100 times work was being done. Simple. So we have to change that. Next. Ratio of manual to machine event is 2:1. There they give you proper fractions. Here they've given you a ratio. It's okay. Whatever my average time is, I will break it into 2 parts, in 3 parts in total basically. One part is 2 and the other part is 1. This 2 is manual and 1 is machine. Rating factor is 115%. Number of articles produced during the study is 6,000. So you've produced 6,000 articles. As per the policy of the company, rest and fatigue allowances are 12% of normal time. Calculate the standard time to produce this article. As usual, let me write down the data and then I will continue. I have my data ready. Let's start with the question. Number 1. And yes, the total time is, here also is 100 hours. Am I right? Yes, on top 100 hours. Done. So for all 100 hours, you are not doing my work. What is happening? Out of which 400 times that I noticed you, out of 2,500, you are not doing my work. So number of not working activities is 400. So therefore, number of working observations is 2,500 minus 400, which is 2,100 observations. Which means that out of 2,500 times that I saw you, only 2,100 times you were doing my work. Which means for all the 100 hours, you were not doing my work. So therefore, time of attended work is, what is the ratio? 2,100 out of 2,500 into 100 hours, which is 2,100 into 100 divided by 2,500. The answer is 84 hours you were doing my work. 84 hours 2 minutes is, multiply that by 60 is 40 minutes. Done? Yes. Let's continue then. Whatever you have produced, then technically you have produced in 40 minutes. How many units have you produced? Let's go back. You have produced a total of 6,000 units. So I'm going to go back and say that 6,000 units require 50-40 minutes. Then 1 unit will require X minutes. So X will be 5040 divided by 6000, which is 0.84 minutes. Per unit. But this time is divided into a 2:1 ratio, out of which 2 is man and 1 is machine. Okay then. So 0.84 is divided in a ratio of 2:1. So 2 plus 1 is 3. So this is 2 out of 3 and this is 1 out of 3. This is manual and this is machine. So 2/3 of 0.84 is divided by 3 and multiplied by 2. The answer is 0.56 minutes. What is remaining? What is remaining is 0.28 minutes. So in the 0.84 minutes, 0.56 minutes is man and 0.28 minutes is machine. So man gets standardized, normalized, man gets standardized. Machine does not get either standardized or normalized. So we continue. Should I finish it on this page only? Okay, I'll write it on a new page. So after this, I am going to say average time is 0.56 minutes. Then I will say normal time is average time into the performance rating or the performance factor, which is 0.56 into the performance rating is 115%. So 0.56 into 115% is 0.644 minutes is the normal time. Now the normal time has to be standardized. Standard time is normal time into 1 plus the allowance factor. Normal time is 0.644 into 1 plus the allowance factor is a 12% allowance factor, 0.12. Increment that by a 12% and your answer is 0.72128. I'm sorry about that, the connection tripped. Anyway, so average time is normalized by multiplying by the performance rating. Normal time is standardized by multiplying by 1 plus the allowance factor, because they say of normal time. When they say only allowances are the 1 minus allowance factor formula. When they say of normal time, it is the 1 plus formula. So I have the standard time for the man. Now I will add the 2, which is the machine, which does not require standardization or normalization. So I will say total time required to make 1 unit is 0.72128 plus another 0.28, and the standard time is 1.00128 minutes. That's my answer. Let's quickly check what theirs is. This is their solution, starting with the bifurcation. So what they've done is, they've first found in percentage how much does it take. So the work is being done 84% of the times, and then you take 84% of 100, which is 84 hours, which is the same, 5040 minutes. Production is 6000 articles. Okay. So per unit, it takes 0.84 minutes. Perfect. Man is 2 is to 3. So 2/3 is man, which is 0.56, and 1/3 is machine, which is 0.28. After doing that, the man will be normalized, and after that the man will be standardized. Once you have a standard time for the man, which is 0.721, you add it to the standard of the machine, because machine is always standard. Add it and your answer is 1.001 minute. Perfect. My answer is also the same, 1.001 minute. Is that right? Yes, 1.00128 minutes. Now what? There is another thing that they have said which I conveniently skipped and I didn't read. So I'll have to go back and read that. And what is it? I'll tell you. There is a part of the question which I didn't read, and this is: given that the shop produces 4,002 articles per month, 25 working days, by 5 workers working a shift of 8 hours per day, consider 7% absentees, compute efficiency of utilization of labor and productive efficiency of labor. Haven't we done this? Haven't we done efficiency and utilization? That is what they mean, no? Efficiency and utilization. How do you do this? I need 3 things: design, effective, actual. Where will I get the design from? Well, simple. You are only telling me, no, that 25 workers are working for 5 days. 5 workers are working for 25 days in 8-hour shift per day. That will be my design. But in that there are absentees. So I will remove the absentees and that will be my effective. And the actual will come from the fact that your actual output is 42,000 units. I have the standard time, which is 1.001. Then I will find what is the actual output that you are giving me. Compare the 3 and I will have my efficiency and utilization. So let's come to having the design. So according to you, the designed is 5 workers working 25 days for 8 hours is a total of 5 into 25 into 8 is 1000 hours. And if 1000 hours has to be converted to minutes, it is 60,000 minutes. So what I have designed my shop for is 60,000 minutes. But the problem is that you are telling me that there are 7% absentees. Now see, if they are absent for 7% of the time, I can't judge them for the time that they are absent. Sorry. I can only judge them for the time that they are present. So what I will do is, for my effective. So I'm not expecting a 60,000 minute output from you. That's okay. From the 60,000, if I remove your absentees, which is 7%, what do I get? Minus 7%. So what is left is 55,800 minutes. Fine. Don't give me an output of 60,000 minutes. That's okay. But at least give me an output for 55,800 minutes. No. You are absent. Fine. I will not consider that. But this output you should actually at least give me. What is it actually that you are giving me? Well, the actual is 42,000 units are produced. But 42,000 units, no. How much time was spent? Well, what time should be actually spent is, I just found you the standard, which is 1.001. So actual is 1.001 into 1.001 minute. And that is 42,000 into 1.001. And the answer is 42,042 minutes. And this is it. I have designed the plant for a total of 60,000 minutes. You are absent for some time, it's okay. Then effectively, I should at least get an output for 55,800 minutes. But that is also what you are not giving me. You produce 42,000 units. Technically, 42,000 units should only take 42,042 minutes. So you are telling me in this much time, this is the only output that I got. Then how efficient are you? efficiency is 42042 divided by 55,800 into 100. Divided by 55,800 is 75.34% efficiency. And how well am I utilizing you? Well, the actual output is only 42042, and I had designed the plant for a total of 60,000 minutes. So much lost. Then how utilized are you, or how well utilized am I keeping you? And the answer is 42042 divided by 60,000. The answer is 70.07%. That's my answer. This always know when they say efficiency and utilization. Productive efficiency is efficiency. Efficiency of utilization is utilization. The moment they put the word utilization, it's utilization. How do you do that? You need three things. Always remember this. What are you designed for? What should you effectively be at least getting? And what are you actually getting? If you have these three things, then efficiency is the actual by the effective, and utilization is the actual by the design. Let's quickly look at their solution. Now, in their solution, let's directly come to the second part of the question. What have they done? Here, this is where I finally found the standard time. Okay. Then they said standard time required for producing 42,000 units is 42042 minutes. Correct? Which is they converted to hours. I've kept it in minutes. 707 hours. Number of days per month is 25. Daily working is 8 hours. Number of workers is 5. Total available working hours is 1000, which I've converted to minutes and written it as 60,000 minutes. Percentage of absentee is 7%. So 930 hours is the effective working. But in the 930, I've converted to minutes. But you are not even giving me that. You are only giving me an output of 700 hours. So that is what you do. Utilization or efficiency is 707. Sorry, utilization is 70.07. They've done utilization first, efficiency second. I've done efficiency first, utilization second. And efficiency is 75.34%. Both is the same. Yes. With this, the chapter time and motion study comes to a sweet end. Let me quickly show you this solution, or let me keep this solution so that if you want to write it down with what I have written. So this is 1. Then this is 2. Sorry. This is 2. Then after this comes 3. After this, and then after that comes 4. That's it. We will go to question papers. Let's write down topic number 6, and that is time and motion study. Very beautiful topic. They could have elaborated. The problem is your syllabus is so haphazardly put. They could have put concepts a little more better instead of putting something now and then repeating the same thing in final for God knows what reason. They could have asked a few things now properly and asked a few things in the final properly. But anyway, this is how it is put out. Let's quickly come to question papers. So the first question paper is going to be the June 17 question paper, obviously. So starting with question number 2. 2A is theory, 2B is theory, 3A no, 3B yes. Calculate the standard time per article produced from the following data obtained by the work sampling study. Number of observations 2600. Number of working observations is 2000. Number of units produced in 100-hour duration is 5000. Proportion of man is 3/4. Proportion of machine is 1/4. Observed rating factor is 120% and allowances are 15% of normal time. And look at this. They've asked you this question for 10 marks. That's massive. So this for 10 marks. What I'm going to do is you are going to create a solution. I'm going to orally do this. So number one, 100 hours is 6,000 minutes. So these 6,000 minutes have to be divided as 2000 divided by 2600. 2000 divided by 2600, multiply that by 100, and the answer is 76.92. Multiply that by 60 is 4615.38. Now in this time you make 5,000 articles, so divide that by 5,000. So the answer is 0.923. Their answer was 0.924. This is 0.923. Fine. This 0.923 is divided into two parts. 0.923 is divided as man as 3/4. So divide by 4, and the answer is 0.3075075. 0.23075. Let me write that down. Multiply that by 3, and the machine is 0.69225. Now after this, the man has to get, man is 3/4, correct. Man has to get 120%. And man has to, so 0.69225, multiply that by 120%. So 0.8307, that gets another 15% as allowance. Add that to the 0.23075, and your answer should be 1.186055. The answer should be 1.186055. Remember, 1.186055. You try it yourself. So let me make a note of that, and please make sure you create a solution right here after this. Time and motion study, one question for 10 marks. Correct? Let's continue. Fine. Frankly, I don't really want to waste any more of your time, because we will waste time running through the question paper, but time and motion study has never been asked again till date. So this is the second paper, which is the December 18. In that, if you see, this is queuing theory. This is we just did this yesterday. This is scheduling, no, and no. Then there is June 18. June 18, if you see, then 2A no, 2B no is EOQ, 3AB is theory, 4 is assignment problem A, B is queuing theory, 5A is we did yesterday and in the previous session, and this is again maintenance management. So no. Then we come to December 18. December 18, 2A is theory, 2B is forecasting, which is done, 3AB is theory, 4A is transportation, which we are yet to do, 4B is maintenance management, is simulation, 5A is CPM input, 5B is maintenance management. So no. Then we come to June 19. In June 19 we have 2A is theory, 2B is we did under facility planning, 3AB is theory, 4A is assignment problems, 4B is queuing theory, then you have 5A we did under scheduling, and 5B is a maintenance management problem. And then the last question paper, which is the December 19 question paper, we are looking for time and motion questions. In the December 19 paper, 2AB no, 3A no, B no, 4A is transportation, 4B is simulation, 5A is project management, and 5B is maintenance management. So that's the last question paper. So If you notice, has been asked just the once. The first time they redefined the syllabus, after that not asked. So if you ask me, then there is a good chance they might ask it to you in your paper. Thank you very much. Very basic concept, only 4 questions. Do them. Thank you very much. I will see you, or I will meet you with a new session and a new concept. Keep practicing, stay indoors, please stay safe. Thank you. Bye.